Discovering Alabama is a production of the Alabama Museum of Natural History.
Beyond the solar system, out past the Milky Way, across the void of space. Every glance across the vastness of space is a journey back in time. Back, approaching a time when the spark of creation put into motion this physical universe. Here in the birth of stars, science seeks the template, the energy, the momentum for what is and what will be. When we gaze upon a distant star, we're receiving light that has journeyed through space for many millions of years. We're actually seeing an image of the star as it once was. Sort of makes you wonder, doesn't it? If we could somehow turn our telescopes around towards the Earth, could we still look back in time? Back to a time when our own world appears alien to us. This is not the landscape of Mars. It's not a moon of Saturn. This is not a scene of past millennia discovered by interplanetary travel. This is evidence of our own world's ancient, very ancient history, yielded by the natural wonders of our own state of Alabama. And here in Alabama, we find evidence of ancient life preserved at the Stephen Minkin Paleozoic footprint site just south of Jasper. Hi, I'm Doug Phillips. These tiny footprints are a remarkable record of Earth's prehistory. They can be found along with other fossilized animal tracks or trackways in a coal field in Walker County, Alabama. Scientists consider this to be one of the most significant finds of fossilized tracks in the world. Join me for a trek among the tracks. Perhaps we can look back across time to a point when the spark of life put into motion the kaleidoscope of diversity we find in our state today. This program is about a land unknown to many people, a land that in many ways has maintained its native natural wonders, a place of bountiful backcountry, forests, streams, and wildlife more diverse than can be found in much of the inhabited world. Come along with me as we explore the wild wonders of this land. Come along as we discover Alabama. Welcome to Discovering Alabama, and welcome to the ancient past. This is the Stephen C. Minkin Paleozoic footprint site in Walker County, Alabama. Until March of 2005, it was known as the Union Chapel Mine. Just a few short years ago, this was a working coal mine. But a few 100 million years ago, this was another world.
Oh, at 310 million years ago? The sun takes about a little over 200 million years to orbit the center of our galaxy called the Milky Way. And so, if you go back 1.5 orbits, which is what 300 million years would be, the sun would have been on the other side of the Milky Way. So we were in a completely different area. But on the other hand, the sun would have been pretty much the same, and the solar system, the planets, they would have all been pretty much the same. The continents would have been different. Alabama was south of the equator and in a tropical zone, which is part of the reason why it was covered with tropical swamp-type forests. And there was a large basin of water in Alabama called the Black Warrior Basin, and it was accumulating sediment off the Appalachian Mountains, which were quite high.
What we think this was a coastal plain flanking the ancestral Appalachians. And consider you have a mountain range forming in the southeast and rivers flowing out of that mountain range. And where the rivers approach the sea, we have deltas and mud flats and things like that. So we think that this was actually near the shore zone where the water was still very fresh and amphibians could live, but in an area that was affected by marine processes enough that we could discern the tidal influence on sedimentation.
A fossil, by definition, is a remnant or a trace of an organism from a past geologic age that has been preserved in the earth. When we hear the word fossil, most of us think of bones, dinosaur bones. What we find at this site are trackways.
Trackways, or trace fossils, are imprints of ancient life recorded in rock. Discovered at the Union Chapel coal mine just south of Jasper, these tracks across time lead us to a very different world.
There are many different types of fossils. The types of fossils that we have here at the Union Chapel mine that are so unusual is that we don't just have a dead creature here. We've got the creature while he was alive. We've got the fact of how he moves across this swamp. We know the types of things that were around him at the time he moved through here. So we have a pretty complete ecosystem that's preserved on this site. And that's what's exceptional about this particular site, is that so much of it is preserved and it is so complete.
There are a few other places in the world that have comparable diversity, such as Joggins in Nova Scotia, but there are no other places that have this volume of material. I mean, look at it. This is only part of the material that the amateurs have brought in for public collections, which they're donating. And we expect to have more now that the site is preserved.
This is extremely important. It was not any exaggeration to say that this is the most important Carboniferous trackway site in the world in terms of the number of species represented and the number of specimens that have been found. For rocks of that age, it's unparalleled. And that's all very important because when you have a lot of specimens, you find rare things. We've got examples of a school of fish swimming along in shallow water and leaving the undulating trackway of their fins on the bottom. And we can see that it was a school of fish because the tracks are all right together. They were clearly made at the same time and they're parallel. There's another example of a bunch of amphibians apparently walking together. And you don't see these kind of interactions, behavioral interactions, preserved unless you have a lot of specimens. And these are the oldest known examples of schooling, the oldest known example of amphibians walking together. I mean, this is just an incredible site for that sort of thing.
I don't know if you can see them, they're so small. Let's see if I can show them to you. It's a small little lizard, like a salamander, or it's been around a long time. Interesting.
It's got to be a little smoother than that, but this redness is probably due to some iron content or higher iron content. But you split rocks, you find some that will split. This one doesn't look like it might split too well.
Out here today, it's hard to believe that this was once a coastal swamp. Many people find it hard to believe that anything in our world can be traced back millions of years. But to a geologist, the evidence is rock solid.
Geologists use a naming system, the geologic time scale, that is best compared to a calendar. It's a shorthand. The days of the week. It's much easier to say, well, something happened last Tuesday, than saying something happened last week between Monday and Wednesday. The coal mine material, like the Union Chapel mine, is from what's called the Pennsylvanian period. It's named for rocks exposed in Pennsylvania where they were first noticed.
The trackways are of lower Pennsylvanian age, and we know the age of these from the fossils that are preserved with them, from the fossils in the coal and things like that. And the Pennsylvanian era was approximately 310 million years ago. This is known actually from correlating coal-bearing rocks all over the world, and we date rocks based on their fossil content, and we actually calibrate them to the ancient record and determine the exact ages using radiometric dates in other areas where datable material occurs.
It's actually pre-dinosaur, these tracks. And that was another thing I think that intrigued the collectors was that these were animals that lived before there were dinosaurs, and not just a short period, but a very, very long period, something like 75 to 85 million years before there were dinosaurs. These animals were walking the mudflats of Alabama, and we know almost nothing about them.
The fossil evidence of Alabama's Pennsylvanian past is exquisitely preserved here at the Mencken Footprint Site.
But it's not just the state's prehistory that's represented here. These trackways are of global significance. And for the trackways to have been preserved in these few acres of Alabama, many things had to come together.
What the Union Chapel Mine represents is a very unique period in Earth's history when, if you've ever heard of the theory of continental drift, the idea that continents are moving, right after that time period, all the continents were assembling into a single supercontinent called Pangaea. And that continental assembly, when those pieces of continents were colliding with each other, is what built up the Appalachian Mountains. That's a continental fender bender between North America and Africa.
It was an amazing confluence of coincidences that led to these little time capsules being sealed for our discovery here at the beginning of the 21st century. No less amazing was the series of events that led to the protection of the site after this discovery.
In December 1999, I remember the meeting very well. One of our members, Ashley Allen, who's a science teacher in Aniana, brought to the meeting several specimens that he had found while he was out collecting. I think a student of his had introduced him to this site, which was a surface coal mine that was owned by his grandmother. And Ashley was very excited to find trackways. Over the next few months, we began having field trips out to this site, and everybody began finding trackways. And we realized after a few months had gone by that the volume of material that we were finding was far beyond what we had the capacity as individuals to really handle. And we further realized that they were probably so abundant that they needed to be, we needed to bring them to the attention of professionals.
Bringing this important discovery to the proper authorities would ultimately mean taking the cause for preservation to the halls of Congress, because federal laws are very strict in requiring the reclamation of open-face coal mines.
For the last 25 years, our agency has been involved in trying to require companies to reclaim these mine sites so you don't have these open pits and high walls left. And this issue that came up with this paleontological site threw us a curveball. The New Acton Coal Company, who mined this site, has bonds posted with our agency to ensure reclamation. And they pay premiums on those bonds yearly. So they're losing money this entire time on those bond premiums. And at the same time, the cost of reclamation is going up.
You can look at this, the terrain here. We had already started reclaiming the high wall back and putting it back like it's required by law, and then these folks come in and discovered these fossils, so we stopped to see if there's some way to actually save this project. And then you know the rest of the history. It took about 5-6 years to actually get this project to where it is today.
All right, Andy and Ashley are going to handle what's going on down here as far as getting the specimens triaged, labeled, whatever. So if you have questions, ask them.
The rest of the history includes valiant efforts to save as many trackways as possible. The Alabama Paleontological Society organized what they call track meets, where members collected and documented specimens for future study.
Now there's colors. Has it changed again? No, the colors are how...
The site was formally dedicated as the Stephen C. Mencken Paleozoic Footprint Site. Steve was probably the most important person in terms of organizing it, and it was really his vision in establishing this index and organizing these tracks.
In 2004, Congressman Robert Adderholt introduced a bill in Congress that would allow the state of Alabama to assume responsibility for the Union Chapel mine.
There was at one point some talk of the survey taking over the site, and that turned out to not be as good an idea as having the State Lands Division do it, because they monitor sites all over the state. They're responsible for other things like this, so they knew how to do it, and they had a group of people in place who could handle it.
Well, the State Lands Division is involved in the protection of a number of unique Alabama sites. This is just one of those sites. As you're aware, the Lands Division manages the Alabama Forever Wild Land Acquisition Program, where we buy and protect unique sites, make them available for the public, for public recreation, and just to protect the site. The State Lands Division is just as committed to protection of this kind of a unique site. It is hugely important that we protect our natural heritage. This is one of the earliest forms of wildlife represented at this site that we know. And it's as important as that we protect the scientific data relating to that wildlife as it is that we protect today's unique places in Alabama.
On March 12, 2005, the Union Chapel Mine was officially christened as the Stephen C. Mencken Paleozoic Footprint Site.
Such a series of fortunate events led to the discovery of this site in 1999. It has been visited and studied by scientists from around the world, including some of the very leading experts in vertebrate paleontology and in fossil trackway sites.
So, a student whose grandmother just happened to own the mine site, just happened to be in a science class, whose teacher just happened to be a member of the Alabama Paleontological Society, which just happened to recognize the significance of the trackways, and just happened to bring it to the attention of the proper authorities.
The list of things that just happen to fall into place might seem like a series of fortunate events, but if we look beyond the happenstance, we discover a couple of important common denominators.
Everyone that we should thank for this, because it's
First of all, the people involved were interested, indeed fascinated, with Alabama's natural heritage. And secondly, these were folks who understood how valuable our natural world can be for education.
This right here is a Wittelsia. It's a seed pod from a seed fern. The ferns that grow around here in Alabama today don't have those seed heads, but the ancient ferns that lived here 310 million years ago did.
One of the missions of the State Lands Division is not only to protect unique Alabama state lands and sites, but it's also to educate young people who will be the stewards of our land tomorrow. If we just protect land today, we've not done very much. If we don't train the stewards, the land stewards, years from now to come. And so we have a huge educational component so that we're trying to teach young people how important it is to protect these areas and how important it is to get outdoors and to enjoy these areas while they're protecting them.
All down in the mud and got preserved, and you found them. It's a great specimen.
Berries off of that tree right over there and squishing.
the plane that people put together that came flying through, and
Well, I'm going to be, I think I'm going to go show my brother around and show him.
The Mencken Trackway site has attracted the attention of scientists and educators from around the state, from around the nation, around the world. But we shouldn't be surprised. Alabama has a long history, you might say, as a place of discovery.
Oh, Alabama is a great state to be a geologist or paleontologist because we have a great diversity of fossil assemblages spanning a very large part of geologic time. And actually many of the most famous fossil localities in the world are in Alabama. And this is one of the places people go to understand how these ancient animal communities lived and functioned, ancient plant communities as well. So this is a very important and rich state in terms of its fossil legacy. By the chemistry of those proteins.
Okay, the work is meticulous, it's time-consuming, the progress is slow. Why in the world do people want to do this? And I think they want to do it because often they've had this childhood interest in old animals, in dinosaur-like things, and Alabama is rich in those things. Part of a larger question is why study these organisms and these animals in the first place, and what do you do with the information once you have it? I think part of the answer for studying anything is the nature of man. Man is a curious animal, and he or she just wants to learn stuff. And you know, why do you read a particular book? Why do you read an article in a newspaper? Why does an old bone you find in the dirt interest you? And I think man is driven by this need to know things. It's inbuilt.
Tracks across time. That's certainly one way to look at these marvelous recordings of ancient times. They take us back, way back. They are the closest thing we may ever have to a written chronicle of our planet's story, as it unfolded more than 300 million years ago.
The tale these trackways tell is a fascinating one, but the story doesn't end eons ago. It continues to this very day, and you have to wonder, where does it go from here?
If you look at what we see preserved in the geologic record, one thing that's clear is that the future is not guaranteed to any organism. There's no system on Earth that is necessarily going to be here in 1 million years or even in 10,000 years.
It's an interesting thing to contemplate, the great amount of time involved in the history of our own planet. It's the vast expanse of time and distance that when we look out at the universe, we were looking back so far in time. We can appreciate the fact that the universe is very much bigger than anything anybody could have imagined, even 100 years ago, how big the universe is. The human experience of being born, growing up, living, and dying, there's more. If we go beyond that, we can try to understand nature from a rational point of view and not be, I think, scared of knowing that the universe might be as old as 14 billion years. But there's still a great deal we don't know. And so you have to put it into a proper perspective, I think. And I don't think people should be put off by the findings of science. I think people should look at it as a positive thing, that we have some idea of where we are in this universe.
In the light of galaxies far, far away, we glimpse the genesis of our own Milky Way, the beginnings of our own solar system, the building blocks of our own third rock from the sun. Across the heavens, we find greater understanding of our physical universe, even while uncovering marvels beyond our understanding. What secrets are yet to be revealed? What insights may yet await us? Stars, in a sense, are the fossils of heaven, taking us into the antiquity of the cosmos. But for all their shining glory, they have yet to reveal the most astounding manifestation of the universe. They have yet to reveal the footprint of life. For that, we have to look to a small but very significant plot of land in Alabama.
Discovering Alabama is a production of the Alabama Museum of Natural History, the University of Alabama. This program is supported by grants from the Solon and Martha Dixon Foundation, the Alabama Wildlife Federation, working for wildlife since 1935, the Alabama Department of Conservation and Natural Resources, State Lands Division,